How many of you here were here last time? Okay, if you remember, we tried to demo the sonars on Loki. Now this isn't Loki, this is called Freya. Freya is a somewhat different version. But everybody keeps, whenever they see this robot, they say, wow, that's a lot of sonars. Okay. So what I want to do here is say, yes, indeed, if you look up at the screen, you can see the sonars. The green one is this sonar, and it's pointing this way. And if I start moving my hand around here, you'll start seeing me blinking off, going around the thing. So as you can see, this is not nearly as good as a LiDAR, but it's not nearly as expensive either. So for low-cost robots, it's worth a shot. Okay? So anyway, I just want to go show you people that it does work. Last time we had a clock synchronization problem. This time we just avoided the problem by not actually running two computers. We just run it on one. So that's what it is. 20 sonars. Each sonar costs about $1, $20. We used to pay $35 to get one sonar not that long ago. So the amazing things of China building lots of cheap stuff. That kind of sort of works. Any questions? Yes, Danny.
Have you used it to mapping and localization?
I'm not planning on using it for mapping. I am planning on using it for object avoidance. So for Ross, that would be basically local cost map. Okay, and I don't know if that's working yet. Is it working, Mark?
I don't have it running.
Okay, we don't. We're really close, but we don't have it working on local cost map yet. Okay, that's kind of it.
You follow that with run what you brung. This is kind of an open invitation for all the other robots. John Erickson will attempt to grasp, what's he going to grab?
He's going after a pill bottle.
Okay,
it looks like
there's a little bottle over here on the table. He's in the other room, and he shall attempt to grab that bottle with the Zybot here. Mysterious Zybot. Is this the Zybot?
Yes, mysterious Zybot.
Yes.
Yes, it's being done teleop. He's around the corner. I think we're using a child, what do you call that, child for here in the other room. I can't think of the name of it. Yes, that's it right there. The complicated baby monitor thing. And what he's doing is he's using that hand to see. He's using it as a pan and tilt. So he gets an idea of where he's at.
Nothing up our sleeves. And John Erickson's operating it after all.
Can't make it fun of you, man.
Does a baby monitor go down?
Yeah, but I don't think he has it up.
Can you see it?
I don't know.
So then he'd be standing at the pedal.
It's more exciting when he's here.
Yeah.
We get to laugh at when he's
Yeah.
We get $4.
Yeah, he's in Sunnyvale trying to grab the bottles. We don't know where he is. From an undisclosed location.
Yeah.
And he was grasping the bottles.
You do it.
Yeah. So,
You lost the camera?
I think it's at home. Yeah, let's try it.
It's the Wi-Fi, it's the other noise.
Yeah, it picks up the camera like every 15 seconds.
They know you're getting close.
There we go. All right, there we go.
All right, go ahead.
stuck on the table like. Land on the table there.
Good luck with that one. That one's tougher.
No, that goes.
No more pictures.
You picked it up.
No more pictures. After that, battery died again. Oh well.
Mysterious Cybot, ladies and gentlemen. All right, are you ready?
Yeah, ready.
All right, Steve okay with the NASA Sample Return Robot Challenge.
Okay, hi. So a bunch of us decided after we did the Microsoft Indoor Connect Navigation Challenge, we were looking for something else to do. We won and the Indoor Challenge, and we were looking for something else to do, so we decided that we would do the NASA Sample Return Rover Challenge, which is outdoors and a lot more difficult, and is build a robot, deploy it to a field that can go out, pick up and retrieve and return to a home base with any number of objects, and do this autonomously and do it in like less than 2 hours. So we were one of, I think, about 12 teams that actually competed. This is at WPI, Worcester Polytechnic University, just outside of Boston. It was a lot of fun. It was a lot of hard work. We learned a lot of things about robots. And I have some pictures here to kind of walk through. And you can go Google for NASA Sample Return Rover Challenge to find out all the details about it. We've talked about it here at the club a couple times, so I'm not going to bother like repeating too much about the basics of the challenge and everything. I'm just going to go through like what happened with us there. So our robot showed up about a day and a half late. This is us bringing it through here.
Team maxed out.
Yeah, Team Maxed Out was the name of our team. This is us putting the robot together, getting out of the crate, getting it set up. I made the blood sacrifice to the robot just to make sure that it worked. Actually, that was an accident. I cut my hand on some copper tape trying to take down the
Hey, it's
antennas.
not a real robot until you bleed.
Yeah, it's not a real robot until you bleed on it. That happened while I was trying to tape down the antennas for our radio direction finder. We had to, the night before we were going to run for our first time in the competition, we had to turn the robot into impound. And so you had to have it into impound by 8 p.m. and it was like 7:56, and I was still trying to tape down the antennas for our radio direction finder. Nicked my finger on some of the copper tape I was using, and I was like, well, if I don't get this tape down, then the robot doesn't get its antennas, and we're not allowed to make any modifications tomorrow morning. So it's like, you know, I kind of took one for the team and for the robot and finished the job. And
Kind of have a blood transfusion.
the first 8 people there got a good workout. You know, they had to actually like, hi, I actually did something, and you have to deal with me now. So these are some of the other robots. People had different interesting approaches to how they were going to pick up these samples. I think everybody's favorite, just like by, just in general by approach, was the Broombot. These guys had essentially a big bristle broom, rotating broom that would just go around and sweep up everything. If it saw an object that it thought was one of the samples it was supposed to pick up, it would just, you know, do one of these things, and basically they also got points for essentially, you know, mowing the yarn and trimming the thatch in the on the competition grounds. This is one of the other robots that this is a team from I think they were from UCLA. They had an interesting approach there. They have some really nice motors. It's tripod configuration. Really nice motors. It's really
Is that Surveyor?
Yeah, that's a sort of team surveyor. That was what they were called. There's a team surveyor.
They got into phase 2, didn't they?
They did. They did not pick up. They did not win because one of their bins did not completely close, and so when it went to grasp the object that it tracked from far away, from across the field, identified and moved over towards. When it went to use the grasp, it realized that it wasn't going to have clearance, and so it bailed on the pickup and went off to find another object and then ran out of time. So they picked up the pre-cached sample. There was one sample that was pre-identified you were supposed to pick up. They picked up that one, and then because their bin didn't close, they didn't pick up anything else.
Isn't that Greg Maxwell in the background?
Yeah. This is out on the practice field.
And Gertz?
Yeah.
Gertz is there.
So,
He's all photobombing as best we can.
so what I did, one of the things that we had to do was, I think we've talked about this before, but we weren't allowed to use GPS, we weren't allowed to use compasses, we weren't allowed to use any traditional navigation methods. You had to do solely visual navigation or anything else other than basically magnetic or Earth satellite navigation. So I came up with the idea of making a radio compass, it's basically a radio direction finder. And the whole purpose of that was that when we were out in the field and it was time for the robot to go home, the robot's supposed to point itself at the base. And we put a beacon back at the base, and the radio direction is using a Doppler method to find the beacon. So the first video I'm going to show is the robot orienting itself to the base with the radio direction finder. So just take a second here. I think we discovered that the pause button was on. I started the code. So here's the robot slewing itself around. It's looking to point itself at the beacon. So there's a and then it did it. And so you can see there from the little dial there that it's pointing at 0 degrees, and so it's basically pointing at the base. So that's kind of part of how we got home.
There's Gertz again.
Yeah. I'm gonna go.
Can you play that video?
Yeah, I'm gonna do that in a second. I want to show one other video really quick here. So I'm just gonna skip for our stuff here. I'm just gonna skip to our the video we have of our robot. The maxed out robot going home. This is after we did our trial. We didn't actually place in the competition. We placed overall, and then our robot was qualified to run, and then we got a demo run, sample run at the end of the day. And so this is after we're going home with the robot, and this is after it's already used the RDF, the radio direction finder, to find home, and now it's just totally running visually. Sorry for the narrow field of view there. I only did this with my front cam.
You can see, aside from the paper blowing around there, you can see our camera is like slewing around there, and so it's looking for the fiducials.
It's looking for the fiducials on our base. We had a set of 4 fiducials, and each had a different fiducial gram on one side or the other, and so that's how the robot knew which side it was approaching from. And so once it had locked onto the a fiducial, it would know which side it was approaching from, and it would do the docking routine. Your courtesies, try again later. What? Try this again here. Yeah. So. Okay, just want to.
Don't close the browser.
Okay, yeah, just give me a second here. I've got this. No, that's not it. One more. Let me just try one more here. I think this is So this should be about this should work. It's the robot rolling around. I think this is from a practice run that we were doing. So this was an awful lot of work. It was an awful lot of fun too. It really takes an entire team to do this, and to do it well and successfully. It takes an entire team of people, not just skilled in their own particular areas, but willing to just jump in on something that maybe you don't even know anything about, and just work together to kind of get it done. I originally signed up to do the radio direction finding, and ended up doing not just that, but also some networking and some power management and a whole bunch of other things. I ended up working with the gripper and gripper control, a tiny G motor controller board. Wrote a lot of code for that. Wrote code for the radio compass. Wrote code and tested out the ROS nodes for the solar compass that we ended up not using, and then also wrote some ROS code for one of the power control systems. So in the end, it was really just everybody jumping in on whatever needed to be done to get the robot actually working. Come and see me later. I've got other videos and hopefully they'll work better.
You run the Team ARG video? Well, there was another Silicon Valley team, Team ARG. Henry, can you come up and say a word about the Army of Angry Robots?
Thanks a lot. Hello, can you hear me? Yes. I'm Henry. I'm the team lead for the ARG team, Army of Angry Robots group. We started our robot, I think, in January 7th, which was the due date for our
Plenty of
application.
Plenty of time.
Yeah, and it was, I think, a team of 5 or 6 of us that put the robot together. It was one mechanical and the rest of us were electricals. This is a quick just video of the robot doing, I guess, a pickup on the practice field. Get this.
You might need to drag the slider back.
Oh, I see. It's already in.
Yeah, just
Got it. Thanks. All right. So our robot was a tracked robot. It had 2 tractor treads with a caster wheel on the back for stability, actually to keep it from rocking back and forth too much. It had a gripper that had 2 independent paddles that would go from either side. And if you can see, there are 2 pressure sensors on the lower parts of the paddles to sense whether it's actually got the object in its grasp or not. Our robot was primarily driven by a stereo vision navigation system that gave us visual odometry across the ground, as well as obstacle detection to avoid running into things. And then we had a separate mono camera that gave us the object detection. Part of the challenge was to pretty much find as many of these objects as you could. The first level challenge was just to find this one particular object that was what they call pre-cached sample, which is just a cylinder with a hook on it. Other things about the robot. I think the visual detection of the robot, of the object, was based on 3 things: texture in the image, color, space, and then size. So the size of the blob tells us whether it's within the right range. Whether it's in the horizon, it's got to be smaller. If it's closer to the ground, then it's got to be larger. I think that's The other requirement for the sample return challenge was that no two objects could touch either. So you had to make sure that your precast sample was sequestered. So our robot actually had 9 bins. There was up to 10 objects out in the field.
Thank you very much.
Sure.
Hang on a second, we can use that browser. Christoph, we got a few more minutes.
Okay.
We're gonna go quick, we got a few more robots. Keep the browser window.
Okay.
Christoph Korstein, ladies and gentlemen.
Okay, so you got like hardly any battery life left, so you better just go. Hey, you know.
Homebrew style, yeah. That goes with the territory, doesn't it?
Yeah, then I guess we started a quick video. This here is Nixie. It's a little flying robot. It allows you to take pictures you couldn't take before.
Thank you so much.
And the video here is the demo we did at the Consumer Electronics Show earlier this year in January. Is there audio as well?
There should be,
Yep.
so you need to turn it up.
Will do.
Yeah, there you go.
Any audio coming out here? Ah, okay, cool.
Wayne's gonna kick us out at 10.
Flick it off your wrist. You don't need a remote control. Can you
Here's
see it live?
Christoph.
I think we should give it a try. Okay, so. Whoa, sorry. I
That's
just
okay,
maximized
that's
the
okay.
window and cut it off.
That's okay.
That's live, that's real. I want you guys to see the flight at least.
How much are those?
That's live, that's real. Just to walk you quickly through what actually happened. So this here turns out it's a wearable quadcopter, so you can wear it around your wrist. Why is that? Because we want you to be able to access your camera right away, and this is super fast accessible. You just flick it off, and then it's ready to go. And why did we make it flyable? Because we want you to be able to capture yourself in the moment. And then, what we did here, what you saw in the demo is, all you do is to toss it. And then Nixie, it's completely on its own. It's fully autonomous, flies out, turns towards you, takes a picture of you, and returns to you, and you catch it out of the air. It's a fully autonomous flight, no need to wear a beacon, no need to have GPS signal even. It's fully based on inertial navigation.
How much?
Still in development, so we don't really know how much it's going to be. But more important for now is actually the fun of developing it. So developing flight controllers for this is pretty much fun and quite a challenge. Then also developing the autonomy of it is a challenge and fun. If you want to be part of it, let me know. And yeah, it's nice showing to you.
Gotta be quick here. Heavy on the demo, light on the talk.
Can you demo it?
They said I don't fly here.
No flying here.
So you've seen a lot of working robots. I would say mine is more aspirational. I do actually have something physical to show for it, though. I took taking 6 months off from work, and during that time, I'm working on something I've always wanted to work on, which is building open source robot arms. And I'm focusing on the hardest challenge first, which is building the joint. Non-Cartesian robot arm joints are very expensive, about $500 a piece. And I'm working on how to make it be about $100 or less. And still be able to provide kind of millimeter accuracy, 4 kilogram payload, and a 1 meter arm. So what I built first is the gear motor for the joint. And some of you actually would say, hey, I saw you had that last month, you made no progress. And the answer is, Actually, I made negative progress. I moved backwards. I realized this joint does not work, and I'm redeveloping a new one. But anyways, I've got a website for it. It's called robotarm.org. I'm doing this for fun. I'm not trying to make money on it or anything like that. I'll probably go back to a product management job like I had before. So, but in the meantime, I'm working on this. So check it out. And this actually does work. It is a 30-to-1 gear reduction, high flow cycloidal gear motor. So if you want to check it out, I'll have it here.
Put it on our mailing list.
Yep. Okay, we'll do.
Next Sunday, ladies and gentlemen. What's that, Bowser?
So the robot will not be doing any magic today. It's just a testing platform for our bigger robot. It has most of the similar parts like NVIDIA, Jetson board and stuff. And while our bigger robot is traveling back to California, we actually have a few parts from the actual robot, and this is one of them.
That remote looks
This is the actual NASA approved pause switch that was operated by a NASA official in competition. And I attach it to this robot, and I think it will probably work. So if we start driving, we'll push a button, it will stop, and if we unpause, it goes again. So this remote in the competition is used to start the run of the robot. All right, that's it for today.
Okay, any more robots? Raise your hand. Come on, somebody's got another robot, don't you? I got a couple more. I thought there were a couple more robots here. I'm sorry for rushing everybody through. So this is Wiry, my little blue robot Wired. Isn't he cute? Thank you. And this is the Snoop Bot. Thank you. Thank you very much. It's a robot made from a puppet. Are there any more robots out there? I don't want to bore you with mine.
I want to point out that at Maker Faire, that robot probably got more attention than everything else we have.
I thought we had 4 or 5 more robots, so I thought we were in really, well, we are in a hurry, aren't we? Okay, I'm going to talk real fast then. This is Rodney Jr., an example of machine intelligence. I've done this several times, and usually it doesn't work. I'm going to give it one more try. I've added something, but my computer's down, so I'm not going to be able to load the new code. But I've got a thinking LED here that shows me the increment and decrement of the confidence level. So the robot's goal in life is to move forward and backwards, which is the only motion patterns in a differential drive system with any magnitude or displacement. And so here he's trying random patterns to try and discover forward and reverse. And looks like he's discovered it. There he goes, forward and reverse. So for this one, I've actually removed the decrement part of it. And then there's 3 levels of machine intelligence. I'll be brief. Alpha, beta, and gamma. Alpha, it's random motions. Beta, when it learns a motion, that a response that's successful, it does that. And then in gamma, it generalizes so that when it doesn't have a beta level response, it uses other high level beta responses before reverting back to alpha. So that's it. Okay, are there any more robots? Did we get everybody's robot out? I want to thank all the participants in the 13th annual HBRC Challenge. I think we had a wonderful time across the board. I had a great time. I don't know about you. We do this again in August and October. Again, this is the all show and tell meeting. It's a deadline. It's an opportunity for you to create. So really looking forward to some enhancements in August and again in October. So thank you very much for participating, and thank you very much for attending. Keep building those robots.